In this video, we're going to go ahead and talk about another type of event, and that's called independent events. Two events in statistics are considered independent if the fact that, let me get my pen going, the fact that the first event happens does not affect the likelihood of the second happening. So an example of this would be successive coin flips. The fact that I flipped heads on the first coin flip doesn't make it more or less likely that I'm going to get heads on the second coin flip. Each coin flip, there's a 50-50 chance of getting a heads or a tails. So we would say that coin flips are independent events. Rolling dice are independent events. Most of the time, we can determine, based on what we know about the system, whether two events are independent or not. Sometimes we will have to figure it out numerically, and we'll talk about that in just a second. But there are some keywords we should be looking for here. If we are drawing cards out of a deck of cards or marbles out of a bag, I'm selecting things out of some larger subset of things, I need to be drawing with replacement in order to be independent. And what this means is if I draw a card from a standard deck of cards, I record which card I drew. I wrote down on a piece of paper, I drew the King of Diamonds, but then I put that card back in the deck and shuffle before I draw another card, so that every time I am drawing from a fresh deck of 52 cards. And what that does is that makes the bottom of that probability fraction 52. It makes those draws independent. If I draw without replacement, meaning I take a card out of the deck and I keep it because I want to hold it in my hand, that's drawing without replacement. And the next time I draw a card, I'm drawing from 51 cards instead of 52. In that case, the probability will change. So those two events would be dependent. So independent is drawing with replacement. Without replacement is dependent. And the important thing here is being able to tell the difference, because just like with the addition rule and mutually exclusive events, for our multiplication rule in the next video, it will look different depending on whether they are independent events or dependent events. And in order to talk about independent and dependent events, we need to talk about something called conditional probability. So I'm going to write the symbol first, and then we'll talk about how to calculate it. So if I want to write a conditional probability, I would write it this way. And you'll notice that vertical line in the middle. So we read this as the probability of B occurring given that A has already occurred. So I know A has happened. Knowing A has happened, what's the likelihood that B happens? So we would read this as the probability of B given A. Likelihood of B occurring knowing that A has happened. And we calculate this sometimes from the structure of the problem if it's a theoretical question, or we can calculate it using this definition. So we would take the probability of both happening and then we divide that probability of both happening by the probability of the condition, the thing that is given, which in this case is A. You'll notice, looking at that formula, that the top is both A and B, and both A and B is the same as both B and A. If I were to reverse these, if I wanted to do the probability of A given B, the top would be the same because it's the same two events, A and B. It's the denominator that changes when we switch the order of that conditional. So B given A is not always equal to A given B. If those events are not independent, they are dependent events, it is very likely that B given A and A given B will be different. So the easiest way to check for independence is we can check that the probability of B given A is just the probability of B happening by itself. That's the fastest way to do it. We can also check that the probability of A given B is just the probability of A. Or I can check that the probability of A and B, of both happening together, is just the probability of A times the probability of B happening by themselves. And depending on which information you're given from a problem, any one of those might work. Some of them will be easier than others based on what you know about your system. The important thing for this video is remembering what a conditional probability is. It's looking at the probability of an event given that something else has already happened, and that we can find B given A as probability of A and B over probability of the condition A. If you have any questions on what you saw in this video, feel free to send me an email or drop by my office hours on Tuesday or Thursday. Otherwise, I will see you in our next video.